Welcome to the deep dive. There's just so much noise out there with cybersecurity news alerts. It's a lot.
It really is overwhelming sometimes.
Exactly. So today, we're going to cut through some of that. We're diving deep into vulnerability management, but specifically for cloud
A
environments.
really critical area.
Totally. We've got this comprehensive report here looking at cloud vulnerabilities, and our mission really is simple. Figure out what actually
Yeah,
matters.
what demands our attention versus, the background noise.
Right. How do we prioritize effectively? Focus on the stuff that poses the biggest, like the most significant risk to your specific cloud setup.
And, the first thing to really grasp, I think, is that the cloud isn't just someone else's computer, right? It's not just your data center moved off-site.
Good point.
Its whole nature, it changes how we have to think about vulnerabilities. The old on-prem playbook, it often needs a serious rewrite.
Okay, yeah, that makes sense. Let's unpack that. So, what are the key characteristics then? What's different about managing vulnerabilities in the cloud? Opportunities, challenges.
Well, on the plus side, the cloud does offer some really nice advantages.
Like what?
Think about attack surfaces. Often in the cloud, you've got much finer control, network segmentation, minimizing what's on your VM images.
Right, you can lock things down more easily.
Kind of, yeah. It makes it potentially easier to shrink those entry points for attackers. That's a big win.
Okay, what else?
Patching speed,
Mhm.
especially for things like serverless or SaaS. Updates can often roll out way faster than traditional on-prem cycles.
Oh, yeah, that continuous delivery model.
Exactly. And another big one is detection. Agentless tooling is becoming more common in the cloud.
So no need to install agents everywhere.
Right, which means you can often scan for vulnerabilities more easily at scale without all that overhead. It's definitely more efficient.
Got it. And you mentioned something about third-party software vulnerabilities, that
Yeah.
they might be less impactful. That sounds interesting.
Yeah, it does seem a bit counterintuitive, doesn't it?
A little. How does that work?
Well, think about how you often consume software in the cloud,
Yeah.
maybe as a managed service.
Okay.
So the underlying infrastructure might be more isolated, and crucially, the patching, the maintenance for that core software, that often falls on the cloud provider, not directly on you.
Okay. So less direct exposure for us, potentially less patching burden too. Makes sense. But what about the flip side, the challenges?
The big one. It's just the sheer volume, the absolute flood of CVEs.
Right. The never-ending list.
Yeah, it's relentless. And the real trick is sifting through all that to find the vulnerabilities that are actually genuinely a threat to your specific cloud setup. Cutting through that noise is, well, it's everything.
Okay, so faced with this, like constant stream, where do we even start filtering? The report we're looking at really leans into technology prioritization. Can you tell us more about that?
Yeah, this is where it gets super practical. Basically, not all tech is created equal in the cloud security game.
Meaning.
Meaning we need to focus our energy on the technologies that are, one, really common in cloud setups, and two, the ones that attackers are likely to see as high-value targets.
Okay, examples. What's in and what's maybe less relevant in the cloud?
Sure. So in is definitely your core compute stuff. Think EC2 instances, Azure VMs.
The basics.
Right. Then your networking components, CDNs, proxies, load balancers, super important. Kubernetes, containers, obviously huge.
K8s, yeah. Everywhere now.
And serverless functions, other VMs. That's the backbone, really.
Okay. And on the flip side, what can we maybe, deprioritize a bit? Or even ignore sometimes?
Well, the report points to things like traditional physical network gear, routers, switches.
The tin.
Yeah, the actual 10.
Hmm.
And like most IoT devices, maybe even user phones, vulnerabilities there were important elsewhere, sure, but they probably don't directly threaten your core cloud infrastructure security posture.
So one less thing to chase down in the cloud context. That's nice to hear.
Definitely.
What about attacks like phishing? Clicking a bad link in Outlook or something. How does that work in the cloud?
That's another interesting difference.
Yeah.
Vulnerabilities that rely on, say, exploiting Outlook or Office, they usually need someone to actually do something, right? Click the link, open
They
the
think about
user interaction.
Exactly.
And while, yeah, you can have virtual desktops in the cloud, most cloud workloads, there are server applications running in the background. No one's clicking emails on your database server.
Right. They're just processing requests.
Precisely. So those user interaction vulnerabilities, while still existing, they're generally way less effective for breaching your main cloud systems.
So if you're used to traditional security where phishing is like public enemy number one.
Yeah, it's a bit of a mental shift. Less clicking matters for a lot of your core cloud assets.
Interesting. Okay. What about software that is common on servers, but maybe not internet facing? The report mentioned Vim, the text editor.
Yeah, exactly. Vim might be installed on tons of your cloud servers,
Hmm.
but is it listening for connections from the internet? Usually not.
So an attacker would need to be inside already.
Pretty much. They'd need some initial access before they could even try to exploit a Vim vulnerability. So it's immediate threat level,
Hmm.
much lower in most typical cloud setups.
Okay. Let's talk operating systems. Everyone says Linux rules the cloud. Is that true? What's the report say?
Our data, yeah, it lines up with that. Linux is definitely dominant across most cloud environments we see,
But
but it's not uniform. There are
Mhm.
differences between the big providers, like Azure. You see a much closer split between Linux and Windows VMs compared to AWS, where Linux is way ahead.
Okay. So your cloud provider choice matters there.
It definitely influences the OS mix you're dealing with.
Got it. Beyond the OS, what about applications, languages? What's really prevalent?
Oh, this is huge. Things like Python, Node.js, they're incredibly popular for cloud development.
And they run anywhere, pretty much.
Right, OS agnostic a lot of the time. So naturally, vulnerabilities in Python or Node libraries, they show up everywhere. Very high prevalence across lots of different environments.
So security teams really need to get a handle on Python and Node vulns.
Absolutely, they're foundational. Understanding the risks there is critical.
And what kinds of apps built with this stuff are creating the biggest attack surface?
The report really calls out publicly exposed web apps. That's a major one.
Makes sense. Customer sites, APIs.
Exactly. And also things like management portals, Jenkins maybe,
Mm.
database admin tools, other admin consoles, file scanners, web crawlers. Anything facing the internet directly is a potential target, especially if it handles data or controls things.
Okay. Now, the report also mentions something interesting, that some well-known software, like if you host your own Confluence or GitHub server, they seem less common than you might think.
Yeah, that's likely down to the popularity of the sauce versions.
Using Atlassian Cloud or GitHub.com instead.
Right. Many companies choose the vendor-managed option. The provider handles the patching, the updates, the maintenance. So that burden is off the customer.
So while a vuln in self-hosted Confluence is bad if you run it,
You just encounter it less often overall in the cloud landscape because so many people use the sauce alternative.
gotcha. The report has this bar chart showing how prevalent different hosted tech is. Can you give us the highlights? What does that picture look
That'd
like?
Sure. And it looks at the percentage of environments affected, which is key, right?
Mm.
It counts for different company sizes.
Right. Normalize it.
So yeah, Python and Linux,
Yeah.
way up there.
Right.
Huge percentage of environments affected. Things like Docker, Node.js, Windows Server 2019, common databases like MySQL, MongoDB, also really prevalent.
Okay. And the self-hosted stuff.
Lower prevalence generally, like
Yeah.
Confluence Server, GitHub Server.
Mm-hmm.
They're present but affect a smaller percentage of environments. Again, probably that sauce effect.
Yeah.
It gives you a good snapshot of where the most common vulnerabilities are likely to pop up.
So based on this prevalence idea, the report talks about a spectrum of relevance. How should we think about that?
Yeah, think of it like a scale. How important is this technology from a cloud security angle?
Okay.
At one end, you've got stuff really specific to the cloud, often high impact. The report mentions CVE 2022-29149. That affects OMI. It's management software used a lot in Azure for configuring VMs remotely. Because it's cloud specific and a serious vuln, it's highly relevant.
got it. And the other end?
More general software,
Yeah.
like that Firefox CVE we mentioned, CVE 2021-5683. Firefox might be on a cloud server, maybe, but exploiting that specific vuln needs user interaction. So for a typical server workload, much less relevant.
Okay. Focus on the cloud-centric, high-impact stuff first.
Right. And the report has this stat. Almost 40% of cloud environments have publicly exposed workloads with vulns in middleware or even in software from the cloud provider itself. That really highlights that high relevance end of the spectrum.
Wow, 40%. Okay. That makes perfect sense. Focus where the risk is greatest in the cloud context. Now, let's shift gears a bit. The report also talks about prioritizing by vulnerability type. Why is that important?
Because the type of vulnerability tells you what an attacker might actually do if they exploit it. It's not just what technology is hit, but what kind of access or control they could get.
Makes sense. So what are attackers usually trying to do in the cloud, according to the report? What are their main goals?
Several key things. Stealing sensitive data, obviously, that's a big one.
Always.
Supply chain attacks using your compromised system to attack your customers. Resource hijacking, like for crypto mining.
Yeah, using your compute for free crypto.
Yeah, still happens. Credential compromise is huge, grabbing keys or passwords to move laterally or escalate privileges, and then just impersonating legitimate cloud resources to do any of the above.
Okay. And how do different vulnerability types help attackers achieve those goals? Which ones are most useful?
Well, they vary a lot in utility. Like for machines exposed to the internet, attackers often just want cloud keys.
API keys, instance credentials.
Exactly. Things they can get from environment variables or the instance metadata service, the IMDX.
Right, the magic IP address that tells the instance about itself.
Yeah. So information disclosure vulnerabilities that leak those keys. Super effective for lateral movement and privilege escalation.
So in that case, maybe a fancy RCE, remote code execution, is actually overkill.
It could be. Yeah. RCE sounds terrifying, and it is bad. But if all you need are the keys, a simple info disclosure might get you there faster and easier in many cloud scenarios.
Oh, interesting.
Same logic applies sometimes to LPE, local privilege escalation. Critical on-prem for owning a box. But in the cloud, if you can get keys via info disclosure, maybe you don't need root on that specific machine right away.
Okay. Now, the report specifically calls out SSRF server-side request forgery as really important in the cloud. Why SSRF?
Ugh. SSRF. It's particularly nasty in the cloud because exploited servers can often make requests to internal services that aren't public.
Stuff behind the firewall.
Exactly. So an attacker can use an SSRF vuln on a public-facing web server to poke around your internal network, access internal databases, or crucially, interact with the cloud provider's own metadata services or other internal APIs.
Like the IMDS again?
Yeah, that's a classic SSRF target. The fact that, big players like Azure have bug bounty programs just for SSRF tells you how seriously they take it.
Right. It's a gateway vulnerability. Okay. The report has this graphic. Exploitation paths in cloud environments. Can you give us the gist of that?
Yeah, think of it like a hierarchy of impact. What kind of access do different vulns give?
Okay.
At the top, highest impact, you've got things like LPE leading to container breakouts or RCE combined with network scanning for wide control.
The really bad stuff.
Right. Then in the middle tier, there's stuff like IMDS abuse, direct data access, impersonation, credential compromise, watering hole attacks, SSRF, which we just talked about, and information disclosure.
Okay. Still very serious.
Definitely. And then lower down, generally less direct impact on the core infrastructure itself. You might find things like cross-site scripting, XSS.
Okay. But the report did mention a specific cloud scenario where LPE is particularly dangerous.
Yes, absolutely. In public multi-tenant environments.
Like where different customers share underlying infrastructure.
Exactly. An attacker might be able to legitimately run some code in their own little corner of that environment. Their next goal is often to break out of that corner.
Escalate privileges.
Right. And a container escape vulnerability is a prime way to do that. Break out of your container, potentially get access to the host system, maybe even mess with other tenant stuff.
Yikes.
Yeah. And the report found that around 20%, 1 in 5 cloud environments, have at least one publicly exposed container host affected by a known container escape vuln. So it's not just theoretical.
20%. Wow. Okay. So we've got tech prevalence, vulnerability type. How do we put this all together? How do we actually manage the CVE flood? The report lists some key questions for vulnerability triage. What are they?
These are basically the questions to ask yourself to figure out the real risk of a specific vuln in your cloud setup.
Okay, let's hear them.
1. What's the cloud value of the tech, meaning how useful is compromising it for an attacker in the cloud? 2. How common is this tech in cloud environments generally? 3. Does it hold sensitive data, or does it usually have high privileges?
Okay, value, prevalence, sensitivity, privilege.
4. What initial access does the vuln give? 5. Does it allow arbitrary code execution? 6. Does it allow access to data on the workload?
Code execution, data access.
And finally, 7. Are there significant prerequisites? Like, do you need prior access? Is it only exploitable in a non-default config? Does it need user interaction?
Got it. So asking these systematically helps you get beyond just the CVSS score.
Exactly. You build a much better picture of the actual impact in your context. Which lets you differentiate between the truly critical stuff and the overhyped stuff.
The report visualizes this with a vulnerability impact quadrant, right? How does that work?
Yeah, imagine a simple grid. Bottom left, low impact, low prevalence. Like a denial of service vuln in a router type you don't even use in the cloud. not a priority.
Okay.
Top right.
Hmm.
High impact, high prevalence. This is your log 4 shell territory effects, common tech, high
Mm.
privileges, easy exploitation. These are your immediate drop everything priorities.
Makes sense. The red zone.
Right.
Yeah.
And the other two quadrants just help you rank the rest based on those two factors, impact and prevalence. It's a mental model for sorting.
Okay. So how do we make this practical? The report lays out a 3-step process to cut down the CVE noise. Let's go through them.
Right. Step 1, use CVSS metrics, but smartly.
How so? What's the smart way in the cloud?
Focus on the CVSS bits that signal high initial access risk in the cloud. So prioritize critical high severity, yes, but specifically look for network attack vector. No user interaction needed, no prior privileges needed.
Things an attacker can hit from the outside easily.
Exactly. And high impact on confidentiality or integrity. That often points to RCE or information disclosure. The stuff we said is really useful for attackers in the cloud.
And availability impact, like DOS.
Generally less critical for initial access and data breach scenarios in the cloud. Important maybe, but not usually the top priority when you're swamped. Their severity in cloud graphic shows this log4 shell, OMI RCE in the top right. Firefox RCE may be prevalent but less impactful for servers. Router DOS in the bottom left.
Okay, step 1, smart CVSS filtering. Step 2.
Integrate external vulnerability intelligence.
Guinea.
Go beyond just the CVE description and CVSS score. Look at exploit databases. Is there a public exploit available? Check the CKV list. Is it known to be actively exploited in the wild?
What attackers are actually using?
Right. And maybe use predictive scoring, like EPSS. How likely is this vuln to be exploited soon? Adding this real-world exploitability intel helps you focus on the stuff that's not just theoretically bad, but practically dangerous now.
Makes sense. And step 3.
Use technology prevalence data, which brings us back to what we discussed earlier.
Knowing what tech you actually run.
Precisely. Your internal data is key here. You take the vulns that pass the first two filters, high severity, likely exploited, and then cross-reference them with your inventory. Which ones affect the technologies you use heavily, especially your critical high-value systems? That's where you focus.
Okay, so apply these 3 filters. CVSS smartly, add exploit intel, then factor in your own tech stack. And the report says this makes a big difference.
Oh yeah, a huge difference. They give an example, like starting with maybe 5,000 prevalent critical high network vulns. After applying these filters, you might get down to a much more manageable list, maybe around 400 or so.
Wow, from 5,000 down to 400, that's significant.
It really is.
Yeah.
Their vulnerability prioritization filters diagram shows it nicely.
Yeah.
Each filter strips away more noise until you're left with a focused list. It shows the power of this layered approach.
Now, what about vulns that are common but don't seem to get patched quickly? The report mentioned that. What can we learn there?
It's interesting. It suggests maybe organizations are making conscious risk decisions.
Like accepting the risk.
Yeah, maybe they figure the actual risk in their setup is lower than the score suggests. Or maybe they have other mitigations in place, WAF rules, network segmentation, whatever, instead of patching immediately. It's a reminder that patching isn't the only response.
Good point. The report also mentioned lots of vulns are in common libraries like OpenSSL or XPath.
Yeah, that's super common. And it highlights how tricky vuln management can be. Just because a scan finds a vulnerable library doesn't mean it's actually exploitable in that context.
Depends how the application uses it.
Exactly. And you might even have multiple versions of the same library on one machine, but only one is actually active or reachable. You need that context.
Okay. And Windows Server CVEs. The report said they're prevalent, but maybe not because it's less secure.
Right. The thinking is it's likely due to Microsoft being pretty transparent with reporting, plus Windows Server is just so widely used, it naturally attracts more research attention, both good and bad.
Got it. And finally, log4shell. Still kicking around.
Oh yeah. The report calls it endemic. It's so widespread, so embedded in things, it's probably going to be with us for a long, long time.
So requires ongoing vigilance.
Definitely. Long-term mitigation, continuous monitoring. It's the new normal for some vulns.
Okay, so we've filtered, we've prioritized based on tech and type. Now, the report really stresses applying public exposure checks. Why is this so critical as a final step?
Because at the end of the day, a vuln only matters for remote attack if the vulnerable thing is actually reachable from the internet, right?
Makes sense if it's locked down internally.
The immediate risk of external exploitation drops dramatically. So checking that public network exposure,
Mhm.
it lets you assess the real-world immediate risk. It separates theoretical vulns from actual reachable attack surface.
And the report's data shows that this makes a big difference in the
A
number.
huge difference. They looked at some legacy vulns, Samba Cry, Eternal Blue, Zero Logon, stuff that's surprisingly still common in cloud scans.
Like Eternal Blue, nearly 20% of environments still vulnerable.
Yeah, something like that based on just finding the vulnerable software. But then when they checked, okay, but is the relevant port like SMB for Eternal Blue or Samba Cry actually exposed to the internet on those
The
machines?
numbers dropped.
Plummeted. For Samba Cry, checking for public SMB port exposure. Relevant workloads dropped to zero in their data.
Wow. Zero.
And Zero Logon, similar story. Maybe 60% of environments had vulnerable Windows systems.
Right.
But Zero Logon mainly affects domain controllers. So they checked, are these vulnerable systems actually domain controllers?
Sure.
The number dropped from around 60% down to maybe 2%.
Okay, those are really dramatic examples. It drives home that point. Presence doesn't equal exposure, doesn't equal immediate risk.
Exactly. The effective attack surface is often way, way smaller than the raw scan data suggests. You have to validate that public exposure and check the specific exploit conditions to focus on what truly matters.
This has been incredibly helpful, really clarifying how to approach cloud vulnerabilities. Before we wrap up, we absolutely want to thank our sponsor, Stonefly.
Yeah, absolutely. Stonefly, they're really pioneers in SAN, NAS, S3 object-compatible storage,
Mhm.
also backup and DR, cloud solutions, and even advanced AI and security tech.
They offer some really impressive advanced data services too. Things like immutable snapshots, which is huge for protection.
Yeah.
AES 256 encryption, both at rest and in transit.
Right, and replication options, synchronous and asynchronous for business continuity.
Yeah.
Intelligent tiering helps manage cost and performance, smart flash cache for speed, and really robust ransomware volume protection.
And they have that patented immutable and air-gapped repository tech, plus control and node architecture, campus mirroring. And you can manage it all up to 128 nodes across different locations from a single interface. That's pretty slick.
It really is. And that patent for immutable and air-gapped storage and backup, that's a big deal, shows real innovation.
Definitely. Plus, they got recognition from DCIG named one of the top 5 storage companies across SAN, NAS, and object storage. That's quite an achievement.
Really speaks volumes. So if you're looking at data protection, performance, scaling up, or just refreshing your storage, whether it's backup DR, HCI, servers, clusters, VMware, Hyper-V, Proxmox environments, Stonefly's worth checking out. Competitive pricing, great support too.
And they're growing. Stonefly mentioned they have over 100 job openings right now. Software engineers, tech support, full-stack devs, digital media, customer service, lots of roles. If that sounds interesting, you can send your resume to jobs@stonefly.com.
That's jobs@stonefly.com.
And they've got a special offer for our listeners this month. You can get started with a $10 immutable and air-gapped backup. Or, check this out, for just $700, a 70-terabyte backup and DR appliance. It's expandable up to 4 petabytes, includes air-gapped and immutable support for Veeam, Rubrik, Commvault, site recovery, plus an advanced AI appliance with object lockdown for ransomware protection.
Wow, 70 terabytes expandable to 4 petabytes for $700. That's quite an offer.
Right. To learn more about that or anything else Stonefly offers, email them at sales@stonefly.com. And their website is just stonefly.com. Check them out, stonefly.com, and sales@stonefly.com.
Okay, so quick recap of our deep dive. We've seen the cloud vulnerability landscape is, well, unique. Opportunities, challenges.
Right, the sheer volume being a big one.
Definitely.
Yeah.
And the key is prioritizing smartly. Not just CVSS, but factoring in technology prevalence in the cloud and the type of vulnerability. What can an attacker actually do with it?
Focusing on that initial access potential, things affecting common, high-value tech.
Exactly. And then that crucial final step, applying public exposure checks, filtering out the noise to see what's really reachable and poses an immediate risk.
So the big takeaway is effective cloud vulnerability management isn't just about reacting to high-severity scores. It needs like a more nuanced, context-aware approach.
You got it. You have to understand the cloud dynamics, what tech is common, the attacker paths, and crucially, is it even exposed?
Which leads to our final thought for you, our listener. How is your organization tackling cloud vulnerability prioritization right now?
Yeah, are you maybe still applying too much of the old on-prem thinking, overlooking cloud-specific risks, or maybe overreacting to things that aren't actually exposed?
Maybe a good next step is to actually investigate the public exposure of your most critical cloud workloads. See what your real attack surface looks like.
It could be very revealing.
Definitely something to think about. Thanks so much for joining us for this deep dive. We hope these insights help you look at cloud security in a new way.
Until next time.